It's a new day. Yes, it is. Hi, folks. Welcome to another session with Mr. Martinez. And for today's class, we are going to be learning how to solve one variable equations. Now, the standard that we're going to be looking at for today is reasoning about and solving one variable equations and inequalities. So, for today's lesson, this is intended for our sixth grade class. We are going to be solving three problems together, and at the very end of the lesson I will be giving you guys a real world example slash extension question that relates to what we are going to be learning today. So let's get started with our problems. So for problem number one, we do have the equation x plus 8 equals 12. Now, how are we going to be solving this one variable equation? Well, we have to isolate the variable on one side of the equation. So as you guys can see here, we have the x on the left side. Pretty much what we're going to be doing is we want to move everything else that isn't the variable onto the other side. So as you can probably see from this equation that we have here, we have a plus 8. Well, how do we move this plus 8 onto the other side? Well, funny you should ask, because there is a way on how we can do this. And the way that we're going to be doing this is by canceling that plus 8. How do we cancel that plus 8? Well, do the opposite operation, which is subtracting. So we're going to be subtracting 8 on the left side. And what happens when you subtract an 8 from a positive 8? Well, again, pretty much cancels out. And we're pretty much left with no 8 on the left side. Now, something to keep in mind is whatever we do on the left side, we also have to do on the right side. So since we subtracted 8 from the left side, we have to subtract 8 on the right side. Now, pretty much just solve this as you would normally would for a regular problem. So 12 minus 8, we are left with 4. Now, after we do this, you can bring everything down. Everything else stays the same. So we have an equal sign and we have the x. So what are we left with? We are left with x equals 4. And yeah, this is the solution for our first problem. Now let's move on to our next problem. Okay, sweet. So now that we're done with problem number one, let's move on to problem number two. Now for problem number two, we have 2x plus 4 equals 8. Now something that I do want to mention before we move on is we are going to be talking about a new term, or we're going to be adding a new vocabulary word, and that word is coefficient. Okay, just keep that in mind. We are going to be coming back to that in a second. Now moving on to this problem, again, same idea as our last one that we worked on together, is we want to isolate the x variable. We want to leave it by itself on one side of the equation, and then everything else we want to move it over to the right side. Now, I know you guys noticed that there is a 2 in front of our x, so let's leave that alone for now, and then we'll come back to that later. Let's try and remove everything that isn't attached to our variable. So in this case, we're looking at a plus 4. How do we get rid of that plus 4? Well, let's do the reverse operation, which is subtraction. So what happens when you subtract 4 to a plus 4? Well, that cancels out. And remember, what we do on the left side, we also have to do it to the right side. So we have to subtract 4 from 8. And what are we left with when we subtract here? Well, we bring everything down and we are left with 4, because 8 minus 4 equals 4. We bring everything down. So now let's talk about this coefficient. So just as a reminder, a coefficient is pretty much any value or number that is in front of a variable. So in this case, we are looking at the 2 that is in front of the x, which is 2x. Now, in order to remove or get rid of coefficients, we have to divide this value by whatever number is in front of the variable. So in this case, we're going to be dividing by 2. Now, why do we divide by 2? Well, because when you divide this coefficient by that same number, it pretty much cancels out. So 2 divided by 2 is equal to 1, and again, that pretty much cancels it out. But same idea applies here. Again, whatever we do on the left side, we also have to do it to the right side. So 4 divided by 2, well, I think it's pretty Pretty self-explanatory. We bring everything down. We're left with x equals to 2. So this is our solution for problem number 2. Okay, awesome. So now we get to move on to problem number 3. Yes, 3. We're moving on to problem number 3. For problem number 3, I want you guys to take a couple minutes, try this on your own, see how you guys can apply what we've been learning so far to this problem. So again, take the next couple seconds, next couple minutes to try this. Okay, awesome. Now that you guys have had some time to work on this problem, let's try it out together. So now we have 10x minus 4 equals 26. So again, how do we isolate that x variable? Well, we are going to be starting off by getting rid of this negative 4. So how do we get rid of a negative? Well, the reverse operation would be to add. So let's add 4 on the left side. And remember, when you add a 4 to a negative 4, that cancels out. And whatever we do on the left side, we have to do on the right side. Again, so we have 26 plus 4. What does that give us when we add these up? We are given with 30. Now don't forget to bring everything down. So we have a 10x equals to 30. Now, as you guys probably noticed, we do have this coefficient of 10. Now, same thing, same idea here. How do we get rid of this 10 in front of the x? Well, we divide by the coefficient value. So 10 cancels out on the left side, and whatever we do on the left side, we have to do on the right side. So what are we left with here? Well, we are left with x equals to 30 divided by 10. Well, the answer here is 3. So because 30 divided by 10 is equal to 3. And this is our solution. This is our answer for problem number 3. X equals to 3. Now let's move on to the extension question. Great job, everyone. So now we have come to our extension question. For our extension question, I want you guys to imagine this scenario. So Maria wants to go to the fair to buy candy apples. If you guys don't know what a candy apple is, this is what a candy apple looks like. Now, keep in mind that a ticket to enter the fair costs $6, and each candy apple costs $2. So if Maria only has $20 to spend at the fair, how many candy apples can she buy? Now, I want you guys to do two things. One, I want you guys to write a one variable equation of this scenario using variable A to represent the candy apples that Maria can buy. And two, I want you guys to solve for A so we can figure out how many candy apples she can buy at the fair. Now take the next couple minutes to try and solve this problem. Thanks, guys.